What is up, math ninjas? Mr. Antonucci here, and in this video, I want to show you the quickest, fastest, easiest way to memorize the unit circle that makes sense. This is what I use in the classroom to recall any value of any of the 6 trig functions for any of the special angles so that I know their exact value. Now, you might have to make note cards and memorize all the special values of the unit circle. You've probably seen something like this where your teacher asks you to fill in the whole entire unit circle and do it in 5 minutes, and that's fine. That's fine. But what I've found is that sometimes when you understand how math works, you don't have to do so much memorizing because you understand how things work and you can kind of derive it for yourself every time. So I'm going to show you how knowing pretty much just 3 values of sine, of the sine function, can and a couple other little subtle things can pretty much help you get any value of a special angle for the entire unit circle anytime you need it. And this is especially helpful because if you're taking AP calculus, there's half of the exam is no calculator portion, and they can ask you to get the value of a trig function for any of those special values, and you just have to know that. And while that may not seem like that big of a deal, sometimes the difference between getting a 3 and a 4 or a 4 and a 5 is just a couple of points. And if this can help you with that, awesome, awesome. And also, you probably have tests and quizzes and assignments, things like that, where you need to know these values. So let's jump in. I don't want to take any more time with the explanation. First thing is all you need to know is sine and cosine. So I know I said that all you're going to need to know is the special values for 3 values of the sine function. But you need to know some things about the reciprocal identities of sine and cosine. Remember that tangent is equal to sine over cosine. So you can get tangent if you know sine and cosine. Cotangent is the reciprocal of that. It's cosine over sine. Again, cotangent, the value of cotangent can be derived from knowing the values of sine and cosine. And similarly with secant, it's the reciprocal of cosine, and cosecant is the reciprocal of sine. So again, if you know sine and cosine, you can get the values of the other 4 trig functions very, very easily. Second thing, all you need is the first quadrant reference angle values. And I'm going to show you a neat trick, because if you know the first quadrant and you know this other thing, you can get the other 3 quadrants very easily because they follow the same type of pattern. And also you have to know the axis points, which are basically the 2 x-intercepts of the unit circle and the 2 y-intercepts of the unit circle. This thing I call ASTC. ASTC stands for All Students Take Calculus. And if you look at the unit circle, I'm just going to draw a quick one right here. It busts it up into 4 quadrants. 1, 2, 3, 4. Okay. All the trig functions are positive in the first quadrant because x and y are both positive in the first quadrant. In the second quadrant, sine and its reciprocal functions or reciprocal function are positive in the second quadrant because sine and its reciprocal function, cosecant, are based off the y value of the coordinate of where the terminal point for that angle is. So in other words, the y value in the second quadrant is positive. The x value is going to be negative, but S stands for sine. So all students take calculus is what ASTC stands for. And you just go counterclockwise, ASTC. And all trig functions are positive in the first quadrant because no matter where you are on the unit circle in the first quadrant, the x and y values are positive. Second quadrant, sine and its reciprocal function are positive because, and we'll get into this in a second, but any coordinate x comma y on the unit circle corresponds to the cosine of that angle corresponds to the x value, and the sine of that angle corresponds to the y value. Okay, and so in the second quadrant, the y values are all positive in the second quadrant. So sine is positive in the second quadrant. X is negative in the second quadrant. So all of the functions that, all the other 4 functions are going to have an x component in them some way. or a cosine component in them some way, and therefore they're going to be negative. Okay. Third quadrant, tangent is positive. And this is because x and y are both negative, and tangent is composed of sine divided by cosine. So since sine and cosine are both negative, when you divide them, you get a positive. So tangent and its reciprocal function, cotangent. All right, in the fourth quadrant, C stands for calculus, or also cosine. In the fourth quadrant, cosine and its reciprocal function, secant, are both positive, and then the other four trig functions are going to be negative. Okay, so this is how it works. A, first quadrant, stands for all. All the trig functions are positive. In the second quadrant, S, all students, sine and its reciprocal function are positive. The other four are negative. Third quadrant, T, take or tangent. Tangent and its reciprocal function, cotangent, are positive in the third quadrant. The other four are going to be negative. And then in the fourth quadrant, C, calculus, cosine and its reciprocal function are positive in the fourth quadrant, and then the other four trig functions are negative. Now, that sounded like a long explanation, but if you just remember ASTC and go counterclockwise through the four quadrants, that'll help you greatly with figuring out whether the answer is positive or negative. That's really the reason we need to know that. Okay. Here's another important point. Complementary angles of sine and cosine are equal. So typically, we're only going to talk about radians here, but one of the three angles that I want you to memorize is that sine of pi over 6 equals 1/2. Okay. The complementary angle of pi over 6 is pi over 3, because when you add those up, they give you pi over 2, which is 90 degrees. Okay, so pi over 6 is, pi over 6, sine of pi over 6 is 1/2. So cosine of its complementary angle, pi over 3, is equal to 1/2 also. Now, I know that sine of pi over 6 is 1/2. I know that cosine of pi over 3 is also 1/2, but then that also tells me that they're reciprocal functions. I can get those values. So for example, if sine of pi over 6 is 1/2, I know that cosecant of pi over 6 is equal to 1 over 1/2, or the reciprocal of 1/2, which is 2. Similarly, if I know that sine of pi over 6 is 1/2, its complementary angle pi over 3, so cosine of pi over 3 is 1/2, which means that secant pi over 3 is the reciprocal of cosine pi over 3, so it's 1 over 1/2, which is 2. Okay, so complementary angles of sine and cosine are equal. You have sine of pi over 6 is 1/2. The other special value that you need to know is sine of pi over 3 is square root 3 over 2. Okay. Well, if you know that sine of pi over 3 is square root 3 over 2, then you know that cosine of its complementary angle, cosine of pi over 6, is also got to be square root 3 over 2. Okay. And then from those two, you can get their reciprocal functions, cosecant and secant. Well, now that you know sine of pi over 6, cosine of pi over 3, sine of pi over 3, cosine of pi over 6, you can expand that to getting tangent and cotangent. So for example, if I know this now, that tangent of pi over 3 is going to be sine of pi over 3 divided by cosine of pi over 3. Well, I know that sine of pi over 3 is square root 3 over 2, and cosine of pi over 3 is 1/2. So if I multiply by the reciprocal, square root 3 over 2 times 2 over 1, those cancel and I get square root 3. So tangent of pi over 3 is square root 3. I could do the same thing with cotangent. Just flip it over. It'd be 1 over the square root of 3, which after you rationalize it will be square root 3 over 3. So we have one more special angle. So you have sine of pi over 6, sine of pi over 3, and then sine of pi over 4, okay, which is square root 2 over 2. Well, the complementary angle to pi over 4 is pi over 4, because pi over 4 corresponds to 45 degrees, and 45 plus 45 is 90. So cosine of pi over 4 is going to have the same value, square root 2 over 2. Okay, works out pretty nice that way. Then tangent of pi over 4 is equal to 1. because it would be sine of pi over 4 divided by cosine of pi over 4. Since they have the same value of square root 2 over 2 divided by itself, you would equal 1. And then cotangent of pi over 4, same thing. Also, all of these angles, all three of these special angles, pi over 6, pi over 3, pi over 4, are in the first quadrant. So I know their answers are all going to be positive. Okay, so keep this in mind. You have to memorize that sine of pi over 6 is a half, sine of pi over 3 is square root 3 over 2, and sine of pi over 4 is square root 2 over 2. You know those three, you can get everything else from that. Because you also know that the sine and cosine of complementary angles are equal. So if you know sine of pi over 6 is a half, then you know it's the cosine of its complementary angle is also 1/2. And then you can just kind of go from there. Okay, so where were we? We talked about how on the unit circle, the x coordinate corresponds to the cosine of that angle that produces that coordinate, and the y value is equal to, corresponds to the sine of that angle that produces that coordinate. Okay, we'll get to that more in a second. Number 6, and this is kind of the last thing. Your answers are going to be one of these 6 or 7, depending how you count it. You're either going to have 1/2, square root 3 over 2, square root 2 over 2, plus or minus 1, 0, or undefined. Now, that is for the basic, the 4 basic trig functions: sine, cosine, tangent, and cotangent. Sine, cosine, and tangent, I should say. But then you can begin to use these ideas of how you get tangent, cotangent, secant, cosecant from just sine and cosine to derive the other values. Okay, so let's jump in and do a couple of examples here. Okay, so if I want cosine of pi over 6, all right, we already did this one, but I know, because we've memorized, assuming you memorized, sine of pi over 3 is square root 3 over 2. That's the complementary angle to pi over 6. And remember, sine and cosine of complementary angles are equal. So this has got to be square root of 3 over 2. Okay. Now, how about sine? Let me scooch this up a little bit. Sine of 7 pi over 6. Now, this is the first one where we are not in the first quadrant anymore. So here's how I think of this. Here we have our unit circle. Okay, 7 pi over 6. 7 pi over 6 is more than 1 pi, because 6 pi over 6 would be pi. We know that pi is halfway around the circle. So if we go to right here, this would be pi units, or 6 pi over 6. To get to 7 pi over 6, we'd have to dip down 1 more pi over 6. Okay, so this would be 7 pi over 6, and now you're dipping down into the third quadrant. Well, if you remember ASTC, all students take calculus, I know that tangent and its reciprocal function are positive in the third quadrant. Therefore, sine is going to be negative. Okay, so I know that my answer is going to be negative. And then its reference angle in the first quadrant is just regular pi over 6. I know that sine of pi over 6 is 1/2. So this is the corresponding angle to pi over 6 in the third quadrant. And so the answer is going to be negative 1/2. And this is how knowing that sine of pi over 6 is equal to 1/2, coupled with ASTC, knowing that I'm in the third quadrant, my answer is just 1/2. But really what I've memorized is just that sine of pi over 6 is 1/2 in ASTC. I did not memorize that sine of 7 pi over 6 is negative 1/2. Okay. Another example, cosecant pi over 4. If I look at cosecant pi over 4, that is equal to 1 over sine of pi over 4. Now, pi over 4 is one of those special angles that I remember, or that I know about sine. Sine of pi over 4 is square root 2 over 2. And so cosecant of pi over 4 is the reciprocal of that, 2 over square root 2. Now, your teacher might not like you to leave your answer like that, so you can just rationalize the denominator by multiplying by root 2 over itself. And then you'd have 2 root 2 over 2. 2's cancel, and you just get square root 2. Okay? So boom, there you go. Another example would be secant 5 pi over 3. I mean, we could pick any angle we want in the unit circle that's a special angle, and we'd be fine. Okay, so secant 5 pi over 3. Now again, 5 pi over 3. Pi over 3, this is a pi over 3 type angle. 5 pi over 3 is more than 1 pi, but less than 2 pi. 1 pi would be, if I think about it here, 1 pi would be 3 pi over 3. If I go one more pi, or excuse me, one more pi over 3, that would be 4 pi over 3. That would put me in the third quadrant. Now to go to 5 pi over 3 would be right here in the fourth quadrant. Also, if I went one more pi than that, I'd be at 6 pi over 3, which is 2 pi. So it's like 5 pi over 3 is almost the whole way around the unit circle, but back up 1 pi over 3. So the reason I'm saying this is so that we know we're in the third quadrant, excuse me, quadrant 4. Okay, and secant is the same as 1 over cosine of 5 pi over 3. In the fourth quadrant, cosine and its reciprocal function, secant, are positive. So I know my answer is going to be positive. 5 pi over 3 has its reference angle in the first quadrant of pi over 3. Okay, we talked previously about how sine of pi over 3 is the same. It's complementary to pi over 6. Cosine of pi over 6 is a half. That's one of the ones I memorized. So cosine of pi over 3 is 1/2. All right. That's the first quadrant reference angle. The fourth quadrant pi over 3 type angles, 5 pi over 3, is going to have the same magnitude or same absolute value, 1/2. So I know my answer is going to be 1 over 1/2. And since I'm in quadrant 4, my answer is going to be positive. So I don't have to change the sign. Since we're dealing with secant, though, it's the reciprocal, or 1 over 1/2, which ends up being just plain old 2. Okay? All right. So just to review this one, because I explained a lot and it seems a little complicated, but it's really not. 5 pi over 3 ends up being in the fourth quadrant. So I know that cosine and its reciprocal function are positive. So secant's got to be positive. 5 pi over 3's reference angle in the first quadrant is pi over 3. And we know from previously that cosine of pi over 3 is a half. So cosine of 5 pi over 3 is positive 1/2 because it's in the fourth quadrant. And then secant of 5 pi over 3 is the reciprocal of that. So reciprocal of positive 1/2 is 2. A lot going on there. So that was secant 5 pi over 3. How about cotangent 3 pi over 2? Now here's something we haven't really talked about, are the points on the intercept. So you have intercept points here. This coordinate, since it's on the unit circle, is 1, 0. All right, and if you remember, this is 0, or the angle would be 0 or 2 pi or 4 pi, because every time you go around the unit circle, you land at this point. So every multiple of 2 pi, so 0, 2 pi, 4 pi, 6 pi, those are going to be coterminal angles. If you remember that the x-coordinate corresponds to the cosine of that angle, and the y value corresponds to the sine of that angle, I already know that cosine of 0 is 1 and sine of 0 is 0. Okay, now I know sine and cosine. I can get the other 4 functions very easily. Right here, this is a quarter of the way around the circle, 90 degrees, or pi over 2, but that coordinate is 0, 1. Okay, because you're on the unit circle, anytime it intersects an axis, it's an intercept, and either the x value is going to be 0 or 1, and the y value is going to be 0 or 1 or -1 for those. We'll get to those in a second. So here I know that cosine of pi over 2 is 0, sine of pi over 2 is 1. And then I can get the other 4 trig functions based on these identities up here. This point, 3 pi, pi, that coordinate is -1, 0. So I know that cosine of pi is -1, sine of pi is 0. Then I can get the other 4 trig functions from that. This coordinate is 0, -1. And again, I know that cosine of, well, this angle is 3 pi over 2, which corresponds to 270 degrees. Okay, it's pi plus half a pi, so it's 180 plus 90 degrees, or 100 or 270, or 3 pi over 2. Anyway, cosine of 3 pi over 2 is going to be 0, and sine of 3 pi over 2 is going to be -1. Well, this is the angle that I'm trying to get the cotangent of. Cotangent is cosine of 3 pi over 2 over sine of 3 pi over 2. Cosine of 3 pi over 2 corresponds to the x value, which is 0. Sine of 3 pi over 2 is the y value, which is -1, so 0 over -1. As a sidebar, had this been tangent of 3 pi over 2, you would have had sine of 3 pi over 2 over cosine of 3 pi over 2, which you would have had the same numbers, but the reciprocal, -1 over 0. Since you can't divide by 0, this is undefined. And if you're thinking of like the graph of tangent, this is where the vertical asymptote would be, if you're looking at the graph of tangent. Let's get into some other stuff, but just wanted to bring it up. Okay, and then one more example, but you just follow this process. Tangent of 7 pi over 4. 7 pi over 4 has a reference angle of pi over 4 in the first quadrant. Okay, tangent is sine over cosine. So what I could do is the reference angle of pi over 4, sine of pi over 4 is square root 2 over 2. That's one of the special ones that we memorized. Pi over 4 in itself are complementary angles, so sine of pi over 4 and cosine of pi over 4 are going to have the same value, square root 2 over 2. So their ratio, sine over cosine, is going to be equal to 1. Okay, that is what the value of tangent of pi over 4 would be. 7 pi over 4 ends up being in the 4th quadrant, because 8 pi over 4 would be the whole way around. 7 pi over 4, you just back up a quarter pi. Okay, and then you'd be in the 4th quadrant. So if you remember ASTC, in the 4th quadrant, cosine and its reciprocal are positive. All the other trig functions are negative. So tangent is going to be negative. So I know my answer would be -1 in that. For the tangent of 7 pi over 4 is going to be -1. Let me put it right there. All right. So I hope that was helpful to you. Just remember, you have to know the values of I put it on this paper. Let me bring it back over. You want to know that sine of pi over 6 is a half. Sine of pi over 3 is square root 3 over 2. Sine of pi over 4 is square root 2 over 2. Know those 3 values. Then you want to know that the sine and cosine of complementary angles are equal. So that helps you get the cosine of those 3 special angles. Then know the reciprocal, the identities for tangent, cotangent, secant, and cosecant in terms of sine and cosine. So now you've expanded your knowledge from those 3 basic special values of sine to cosine to also all 6 trig functions now. And then you remember ASTC, all students take calculus. This helps you remember what the sign, SIGN, of your answer is going to be. And then you remember that the x and y coordinate corresponds to the cosine, corresponds to x, and the sine corresponds to the y value. And then the other thing is just the axis points, and those are pretty self-explanatory. And then you can use the first quadrant reference angle to figure out its corresponding angle in any other quadrant. You use ASTC to figure out the sign. So guys, I know that was a lot. You might want to go back and watch this again. But once you get this process down in your mind, you really only need to know the 3 values of sign for pi over 6, pi over 3, pi over 4. And then remember these couple other details. And you don't have to memorize the entire unit circle because you understand where these values are coming from. And you can bring this forth at any time you want from now on. All right, guys, hope that was helpful to you. Make sure you subscribe to the channel. If you're not subscribed, hit the bell for notifications and drop me a comment below. Let me know if this was helpful to you in any way, shape, or form. All right, take care.